Here's an example of a lesson that highlights the mathematician-engineering cycle. It involves city planning and the beautification of neighborhoods. Throughout the city, plots of grass called green space are being preserved, with sidewalks surrounding them. With this configuration, we can see that for 1 square of green space, we have 8 squares of surrounding sidewalk. Now, if we had 2 squares of green space, then we would use 13 squares of surrounding sidewalk. As we continue expanding, when we configure the next largest expanse for our cityscape, we have 3 squares of green space and 18 surrounding squares of sidewalk. At this point, before building the next largest expanse, try to determine the number of sidewalk squares that will be needed when 4 squares of green space are planted. You should find that 23 sidewalk squares will be needed. Try to determine how many sidewalk squares will be needed for 5, 10, and 35 green space squares. Try to do this without drawing or building a model. And now for the algebraic leap. Explain how you can find the number of sidewalk squares that would be needed for any number n of green space squares. In essence, we're trying to create a formula with n being the green space input and the output being the number of sidewalk squares. Hold on though. Just because you found a formula that works for the data, the bigger question is, how does the formula manifest itself in the physical phenomenon? That's when you know the system you've imagined really and truly works.